We have an equation y equals to x cubed minus 6x squared minus 15x, and we have to differentiate this. So let's first assume that we have an equation y equals to x to the power of n. If we have y equals to x to the power of n, to differentiate it, I will bring the power down and I will subtract 1 from the power. So that's how we differentiate a polynomial. So if we look at the equation over here, we have y equals to x cubed minus 6x squared minus 15x. So to find the dy by dx, for x cubed, I will bring 3 down and subtract 1 from the power. And for 6x squared, I will bring 2 down and subtract 1 from the power. And for 15x, I'll subtract 1 from the power again. So that leaves us with 3x squared minus 12x minus 15. Why minus 15? Because x to the power of 1 minus 1 is x to the power of 0. So if we highlight this over here, x to the power of 0 is equal to 1. So that means 15 times 1 is going to be 1. Curve with the equation y equals to x cubed minus 6x squared minus 15x, which has 2 stationary points. Work out the coordinates of these 2 stationary points. So to work out the coordinates of the stationary points, we will differentiate the equation. Dy by dx is going to be 3 times x to the power of 3 minus 1 minus 6 times 2 times x to the power of 2 minus 1 minus 15 times x to the power of 1 minus 1. So that's going to be 3x squared minus 12x minus 15. At a stationary point, your dy by dx is always equal to 0. So it's going to be 0 equals to 3x squared minus 12x minus 15. Now we factorize this. Before we factorize this, let's simplify this further. We know that 3 is common between all of these terms. So 3 bracket x squared minus 4x minus 5. So now we have x squared minus 4x minus 5, which is a much simpler equation to factorize. So it's going to be x squared minus 5x plus x minus 5, which is going to give us 0 equals to x brackets x minus 5 plus 1 bracket x minus 5. X minus 5 is common, so x minus 5 times x plus 1. So one value of x is 5 and the other value is negative 1. So now as you see in the question, it said coordinates of the stationary point. So now we have to find the corresponding y values. And in order to find the corresponding y values, we will plug the values of x in the original equation. So at x equals to 5, y is going to be 5 cubed minus 6 times 5 square minus 15 times 5, which is going to be 125 minus 150 minus 75. So that will equal to negative 100. So when x is 5, y is negative 100. And at x equals to negative 1, what we will have is y equals to negative 1 cubed minus 6 times negative 1 whole square minus 15 times negative 1. And that's going to be negative 1 minus 6 plus 15, negative 7 plus 15, and that's going to be 8. So when x is negative 1, y is 8. So your coordinates are going to be 5, negative 100, and negative 1, 8. That is your answer for this question.